Okay, good afternoon, everyone. For those of you who don't know me, I'm still a teacher of this course. I'm Alberto, and I'm the teacher of the slot about health and well-being in the lab. And here, this week, and also the next two, I think, we will see together something about evaluation and also something about medium fidelity prototyping, okay? But today we will start the topic of related to the evaluation, of course, in the human-computer interaction field. So today we will see an introduction of the different evaluation techniques that we can use in our field, and then we will focus on one specific technique, that is heuristic evaluation. That will be also the focus of the assignment number 3. Tomorrow, hopefully, we will do some examples and one exercise on this topic. So you should have already seen this figure. These are the 4 pillars for designing a good user interface. We basically started with need finding, then we started prototyping something according to some guidelines and theories. And today we start the last pillar, that is the one about evaluation. And the important thing here is that we can use also guidelines, principles, theories. We can use them for designing, but we can also use for evaluating, especially in the expert evaluation techniques like the heuristic evaluation. So we'll see how we can apply some concepts, some guidelines, some principles to evaluate something that are being prototyped. The other important aspect here, and I will repeat it in this lesson, I think at least twice, is that evaluation is not something that happens at the end of the design process. But you should typically have different evaluations in your process because, as you probably already know, this process is something iterative. Okay, so what is the disadvantage of having one single evaluation at the end only? The problem is that you probably need 1 year of development, then you maybe upload your mobile application on the Play Store, and then you discover that your application is terrible, is not usable. And so you need to start from scratch. So here the idea is having multiple rounds of evaluations with different evaluations according to the design phase so that you can correct, you can fix problems as soon as possible. Okay, this is the key idea of today. So what does it mean evaluating something in human-computer interaction? It means testing mainly 3 things: usability, functionality, and acceptability of an interactive system. And we will focus specifically on usability. And again, this is something that happens multiple times in the design process. And according to the design stage, there are different evaluation techniques. Of course, evaluating a low-fidelity prototype is different than evaluating a final implementation. And so we can use a range of different techniques. Again, the goal is identify and correct issues as soon as possible. So first aspect that we can test is usability. You probably already know what is usability. Just to recap, usability can be defined as how well users can use the functionality of the system. And clearly you can specialize this dimension in different ways. We can focus on usefulness, so is the system something people want or not? We can test learnability. Is it easy to learn, or every time the user opens your app, the user needs to learn from scratch how to use it? Memorability, effectiveness. So we started from need finding, so we identified some needs, and we also defined some tasks. So is your system able to support users in performing these tasks? To what extent? Then there is efficiency, visibility. Visibility is more about the state of the system. Is it visible or not? Errors are there. Of course, users will do errors in your system, but can they recover from these errors or no? Sorry, the mic died. I don't know why. Let's see if we can. Okay. Yes. No. Okay. And then there can also be satisfaction. So is the system enjoyable to use or not? Then the second aspect that we can test in the evaluation is functionality. And again, here we can test if the functionality of the system are compliant with the needs of the users. So this is why we started from the needs and we define some tasks. And we can also test if functionality are clearly reachable by the users. And of course, here we can also focus on the performance that the user can achieve with the system. And finally, the last aspect that we can test is acceptability. That can be defined as the degree to which the user will accept the system in their daily life. Okay? So here we can, of course, if a system is usable, is useful, it will probably also be accepted by the user. So these three aspects are in some ways linked together. Here we can also, again, focus on measuring satisfaction and comfort, and this also means sometimes identifying areas of the design that can overload the user. So we will see also some design patterns in a next lecture, and we will also learn that this kind of design patterns can also become dark patterns, so patterns that are deliberately adopted by a company against the user. And one of the patterns that is really related to this identifying areas of the design that overload the user is the usage of guilty pleasure recommendations. So recommendations that are displayed on an interface just to capture the attention of the user. So if you have a page with millions of recommendations, this area probably is a part of your interface that could be improved because it may overload the user. And this also negatively influences acceptability in this case. Okay, but let's start to focus on the evaluation and the differences that we can find in these evaluation techniques. And the first distinction here that we can make is about the place in which you perform the evaluation. We can have evaluations in the lab or in the field. So in lab studies, users are typically taken out of their normal work, their normal activities, and you ask your participants to come in the lab and to test your, for example, prototype for 1 hour. Okay? These kind of evaluations are typically adopted at the beginning of a design process, mainly because you don't need a final implementation for testing something in the lab. Okay? So what are the advantages of this technique? Of course, you can simulate also dangerous behaviors in the lab. So, for example, in the aerospace domain, before sending an astronaut into space, you probably need to check in the lab if your interface in the spaceship is usable and understandable by the astronauts, right? And also in the medical domain is another example in which lab studies are needed at the beginning, okay? So you can simulate a dangerous environment. It's also suitable if you have specific tasks to be performed, and so that's why you define tasks in this course. But what are the disadvantages here? Of course, you lack the real context because you are in the lab, and probably participants will know that there is someone that is observing them, and this can create biases in how they use your system, okay? So there can be unnatural situations leading to biases, and these kind of evaluations are, of course, not suitable for all the tasks. If you have a mobile application, maybe already implemented, that tracks running sessions, testing this kind of application in the lab, it's probably not suitable, okay? So it depends also from the tasks that you are investigating. On the other hand, you have field studies. So here the designer, the researcher, goes into the user environment in order to observe the system in action. You upload your application on the Google Play Store, you ask your participants to download and install the application, and you ask them to use it for 1 month. And in this month, you collect data, you perform interviews at the beginning, at the end, in the middle of the study. But again, here there is the system, the real system working in the field, okay? Of course, the advantage here is that you have the real context of the user. So users are in their natural environment. On the other hand, you have a low degree of control. Because in a lab study, you can control the environment, right? You simulate the context. In the real world, you cannot do that, of course. So what is the risk? You upload your application, you ask your users to download and install it, but maybe the user has a very specific smartphone that is not compliant with your implementation. And after 1 hour, your application crashes and you cannot extract any data from this participant. So you have a low degree of control, and you also have a higher cost, and because you need here probably a final implementation, and these kind of experiments typically are typically longer. Again, one session in the lab can last 1 hour, typically. An in-the-wild study typically lasts at least 2 weeks, 1 month, it depends, okay? Another distinction that we can make about evaluations in HCI is related to the participants. We can have expert evaluations and evaluations that involve the target population. So let's start with the expert evaluation. Here I listed 4 techniques. We will focus specifically on the last one, heuristic evaluation. So here we are giving our system, our prototype, our final implementation to some experts, and we ask these experts to check our system and identify possible problems, typically related to usability. So it's useful to identify any areas of our system that are likely to cause some problems with end users, because experts know that these problematic aspects of your system violate some heuristics, some guidelines, some theories. So it can be used at any stage in the development process. It is relatively cheap because, as we will see, you typically need 3 to 5 experts to check your design. And it is mostly used to solve easy to solve problems. So problems for which we don't need the target population, okay? If there is a gray text on top of a black screen, we don't know probably the target population to understand that our text is not visible at all, okay? We can ask an expert for this. What is the drawback? We don't have the actual use of the system. So we cannot evaluate if our system is effective with the need of the target population. On the other hand, we have evaluations that may involve users. And here I also listed some techniques. We can have experimental and observational methods. We test some hypotheses looking at users using our system, so we get empirical evidence. And we can also have query methods or also interviews. You used interviews in the need finding method. You can also use interviews as an evaluation technique. You ask some users to use your system, and then at the end, you perform an interview asking pros and cons of using this system, perceived advantages, disadvantages, and so on. Of course, interviews are easy to conduct typically, but you get subjective results. And then you can also have automated evaluation that are mostly related to software simulation, formal methods, and techniques. We will not cover this evaluation in this course. Okay? Any questions? So this was a very brief introduction of the evaluation techniques that we can find in HCI. Again, now we will focus on heuristic evaluation. That is a kind of expert evaluation technique because it will be also the focus on the assignment 3. In the assignment 4, 5, I don't remember the number. So for the exam, you will also be asked to conduct a usability test. So a test that involves the target population. But again, let's focus on heuristic evaluation. We look for usability problems, asking to experts. This kind of evaluation is also called design critique, because experts will critique your design, of course, in a constructive way. And you will take the role of experts in assignment 3, evaluating the prototype of another group, evaluating probably 2 prototypes of another group. So when is this kind of evaluation useful? Again, you can use it at different stages in the design process. It's easy before user. It's common to use it before user testing. So before going to the target population, you try to solve the easy to solve problems with the experts, because this saves effort, and you can use user testing for the bigger issues. You can use it before redesigning. Maybe you have your version 1, you want to produce the version 2 of your application. You conduct a heuristic evaluation to identify the good parts and maybe the parts that should be actually redesigned. You can also use it, and it's typically used to generate evidence for problems that are known or just suspected. Maybe you have your application on the Play Store, you are starting to receive very bad reviews, so probably there are some problems, you still don't know exactly what are these problems. You conduct an heuristic evaluation to investigate this kind of things. And also before releasing the final implementation, you can conduct a final heuristic evaluation to be sure 100% that your application is useful. Okay. This method was proposed by Jakob Nielsen. Jakob Nielsen is an HCI researcher that is working with Don Norman. You should already have heard about Don Norman before in this course. It's a structured design critique because it is based on a set of heuristics. What is an heuristic in your opinion? Can you define an heuristic? What is the definition of heuristic? Any definition? No. It's something like a general principle, a rule of thumb, so something that we know that we should follow. Because maybe it has been followed by other designers, other researchers, and we know that this kind of are in some ways validated by a sort of history of design. Okay, so well-known principles, well-known rule of thumb, something similar to the principles that you have seen in the past lectures. Okay, you generate evidence on the basis of this kind of heuristics that are in some ways validated, so it's not a subjective evaluation, it's more objective. Again, it's executed by a small group of experts, 3 to 5, and we will see why there is this magic number. And again, the goal is to find usability problems in a design. It's also common to call this technique as discount usability, mainly because it's a cheap method. You only need 3 to 5 experts to conduct this evaluation. And this is the basic idea. Obviously, you can find more details online, also in the Nielsen-Norman group. You define a set of heuristics, but typically in our field, in the human-computer interaction, you use the heuristics proposed by Nielsen, so they are already defined. You give those heuristics to a group of experts, and each expert will use these heuristics to check your design. And the third point here is very important. Experts first work independently. So each expert will find different problems. And then at the end, there is a consensus phase in which experts share their findings and try to reach an agreement and produce a final report that is given to the design team. And this report is used by the design team, of course, to refine and improve the design. So Nielsen proposed 10 heuristics to find usability problems in a design, and we will see them in detail. And of course, they are mainly inspired to the design principles that you have already seen, so there will be some overlap. Of course, in a specific context, in a specific application domain, you can also decide to define your own heuristic. So if your design, if your application is related to, I don't know, human-AI interaction, a very specific domain, you can also think about defining your own heuristics and test your design with these specific heuristics. But in general, you typically use the one proposed by Nielsen. Also in our case, of course, not all these heuristics are applicable to your design. It also depends on the design phase in which you are performing this evaluation. Because, for example, there will be some heuristics that are more related to fonts, colors, images. Of course, these heuristics apply only minimally to a low-fidelity prototype that is in black and white. Okay? So it's normal that some heuristics will be, let's say, ignored in your evaluation because maybe they don't apply to your specific design phase, that in our case is low-fidelity prototyping. So in detail, these are the phases of heuristic evaluation. In the first phase, you typically have a pre-evaluation training because, of course, your experts will be experts in human-computer interaction, but maybe they are not experts of your specific domain. For example, if you are developing something for doctors, maybe a human-computer interaction expert needs some training about the medical domain, just to be sure that the expert can use the system normally and understanding all the labels, all the acronyms that are displayed in the interface. So there can be this pre-evaluation training because, again, the evaluator can then try to impersonate a user of the target population. Then there is the individual evaluation. Again, experts first work independently and produce an individual report. And this individual report will be the output of the assignment number 3. You will produce an individual report, and this report will be evaluated by us to give you these 4 points for the exam. In this evaluation, you should also assign a severity rating to each problem you will find in the interface. Then you can reach an agreement with your team of experts. So you will discuss in your group the violations that you will find in the individual phase, and you will try to aggregate this in a aggregated report. And finally, this report is given to the design team. In this case, you will give your shared report to the other group so that the other group can decide, for example, which prototypes is better, okay? But again, for the exam, you will be asked to upload the individual report only. Of course, before asking experts to try your system, you should define a set of tasks, and you already defined the tasks in the assignment 2. So the evaluator can use these tasks to try your system, your interface, and find usability problems. And for each task, the evaluator typically performs multiple times these tasks. In a first step, the evaluator can try to perform the task just to get the general feeling of the interaction. Then the evaluator typically re-performs the same task, focusing on specific elements on your interface. And again, heuristics are used as a reminder of things to look for. There may be an observer in this kind of evaluations, taking notes, and the observer can also provide clarifications, especially if the evaluator is not an expert of the domain of your system. In your case, one member of the group will also act as the computer, trying to simulate the prototype that is on a sheet of paper. Of course, it's important not to give any suggestion on how to perform the task to the evaluator. You can maybe clarify, I don't know, a specific term or a specific sentence, but you cannot tell the expert how to do the task. Otherwise, it's not fair. The duration of an heuristic evaluation is typically 1 hour, 2 hours, but in our case, we have a limited prototype, so probably this time will be shorter. And each evaluator should provide this individual report with a list of usability problems. What is a usability problem in this case? It's a violation of a given heuristic. So each problem should be clearly connected to an heuristic. This is a violation of heuristic number 3. And each problem should be reported separately in detail following a well-defined template with a severity rating. So this is a very big problem. This is a low fidelity problem, a low priority problem, sorry. And we will see also a scale through which you can assign this degree of severity. Where can we find problems here? We can, first of all, find problems in a single location in the user interface. There is maybe, I don't know, a button without labels, just with an icon, and this icon cannot be really understood by a user, by the expert. A single location in the UI that is problematic. We can also have problems in 2 or more locations that need to be compared. For example, the designer is using different labels for buttons that provide the same functionality. Maybe in the home page there is a button with search, and in another page there is a button with the label find. Is find the same of search? Who knows? So inconsistencies in the labels, for example. We can also have problems with the layout of the pages, the overall UI structure. And these problems arise when the designer is not following conventions on a given platform or for a given device. For example, I don't know, if you are evaluating a website and this website has the nav bar on the bottom, this is really strange for a website, right? So this can be a violation of a given heuristic that we will see, because the designer is not following the convention that the nav bar for a website is typically on top of the page. And also, there can be something that is missing, okay? So maybe there is an important task, there is a button for deleting something, and you are not providing any feedback about the result of this operation. Or you are not asking confirmation for a dangerous operation. So here you are missing some feedback, okay? So something missing. Of course, this can be a problem, but in some circumstances, this can also be due to a prototype approximation. So, for example, in your case, you will evaluate a low fidelity prototype. So it is normal that some parts of this prototype are not implemented. And so it depends on the design stage. So Nielsen also conducted some experiments to find this magic number of evaluators that you need to conduct a good heuristic evaluation. So, for example, here he conducted an experiment. He designed a fake user interface in which he deliberately inserted 16 usability problems, and then he asked 19 evaluators to check the interface and find as many problems as they can. And as you can see, this magic number, of course, cannot be 1, because no evaluators found all the problems. But there is a substantial amount of overlap, right? So with 5 evaluators, you will find probably most of the problems here in this experiment. And this magic number was confirmed by other analyses. Here you can see the ratio between the problems found and the number of evaluators. It's not linear. After 5 evaluators, this ratio tends to stabilize. So, and the advantage of having other 5 evaluators is really minimal. It's about, I think, 10%, 15%. And of course, the cost of recruiting more experts increases, and so the advantages of having more than 5 experts decrease. So with 5 experts, you typically find 75% of errors, and that's fine for this kind of evaluation. And what about severity rating? So of course, the design team need to allocate resources to fix the bigger problems. And severity here is a combination of 3 things mainly. So the frequency. Is the problem rare or common? Is the design problem present in all the pages of your prototype, or is it a specific of a single page? The impact of the problem. Can the user interact with the system even if there is that specific error, or is the error blocking the user? And the third aspect is persistent. So is the problem happening every time I click on a button? Then it's probably a severe problem. Or is it something that happens only just the first time that I click on the button and then it disappears? So you can consider these three aspects to define the degree of severity of a given problem. And of course, this is also defined first individually, and then you try to reach an agreement in the consensus phase. And Nielsen proposed this scale for assessing problems from 0 to 4. So the 0, that means no problem at all, is typically not used in the individual phase. Yes?
I usually understand the specific difference between persistence and frequency.
Okay, frequency means the frequency of the problem in your different pages. Maybe you have a problem that is related to all the buttons in your interface. Okay, all the buttons in your interface are badly designed. Persistency is more related to the interaction of the user with your system. So as you probably know, there are errors that happens one time during the interaction, and errors that instead happens every time I click on that button.
So persistence is more about one single thing of the interface?
Yeah, it's probably related to a single part of the interface, okay? So if you perform something, and while performing something you also fix this error in some ways, this is a not persistent error probably. If every time you click on the button there is still this error, it's probably a persistent error, okay? So again, 0 is not used in the individual phase, is used in the consensus phase. So in your group, maybe 2 of you have discovered an error, and another component of your group didn't discover this error, and in her opinion, that's not a problem, okay? And she gives 0 to that problem, and you can compute the average, you can use whatever strategy you want to reach an agreement. Then there are cosmetic problems only, rate 1. So as the name suggests, this problem don't need to be fixed by the design team unless there is extra time for the design team, okay? Are very specific, very minor problems that can be fixed, yes, but just at the end, if the design team has enough time. Then there is rate 2, minor usability problems. So fixing this should be given low priority. Please, design team, start with obviously the high priority ones, and then try to fix the low priority. 3, major usability problems. These instead are very important to fix, so should be given high priority. And then hopefully you will not use 4, but 4 means usability catastrophe. So it's imperative to fix this problem, otherwise the product, the system cannot be used at all by the user, okay? Again, in the consensus phase, in the discussion phase, you should try to reach an agreement on your violations and also on the severity of these violations. And you mainly have 2 different strategies. You can just discuss in your group and try to reach an agreement, or you can also try to compute the average of the different scores that you have given individually. And you can also adopt these strategies in assignment 3. And finally, typically there is this debriefing phase. You will not be asked to perform this in assignment 3. You will just need to give the shared report to the other group, but typically experts meet with observers and also the members of the design team to discuss line by line the produced report. And the experts can also give some suggestions to the design team on how to improve, how to fix the violations that have been found. Okay, I think we can skip these slides and start focusing on the heuristics proposed by Nielsen. These are 10 usability principles to be used in heuristic evaluation. You can find a lot of documentation online. Here I linked also some videos taken from the Nielsen-Norman group. Of course, you don't need to remember exactly these heuristics. Also, during assignment 3, you can maybe have these heuristics on the tablet, or you can print them. You don't have to remember them. And these are the 10 heuristics. We will see each of them with some examples. So, heuristic number 1, visibility of system status. Again, there will be some overlap with some principles that you have already seen. The system should always keep users informed about what's going on through appropriate feedback within reasonable amount of time. So I'm filling out a form or a multi-step process in general. Can I understand easily my current position in the form? Do I have some indication about how much time I need to complete the form? So feedback. And when I submit the form, do I receive a confirmation message or feedback? Some examples. If there is the green face are good examples, it will be red for bad examples. Here, all of these screenshots can be considered, in my opinion, good examples. So, for example, here in this mobile application, there is this progress bar on top that is indicating that 3 out of 5 images are uploaded. So the user is well aware of the progress and can wait the process, knowing how the process is going. And if the user clicks on the progress bar, she can receive even more detail. Okay, so that's a good example. Then there are examples of feedback in real time about passwords. This is very common. And also here, this is typical in, for example, social media on a mobile interface. Oops, sorry. There is this, I don't know how to call it, icon, something like that, this progress indication that also resembles how the content will be displayed in the page. So while I'm waiting, I already know, in a way, what I will see after. So it's a good example of feedback. So it's a sort of a smart placeholder. I can provide different kind of feedback to the users, of course. I can provide feedback about time, execution time for tasks, about space, the occupation of my cloud storage, about action, so to show users what is happening. We can also give some suggestions for the next steps. And it's also important to give feedback about completion, so clarify when a task has been finalized. Okay, I deleted something, I have a confirmation message. And this is a rule of thumb about time. So if the execution time is less than 1 second, your interface can just show the outcome of the action. If it's around 1 to 2 seconds, you should show feedback that the action is underway. So like, for example, with a loading icon. If it's more than 2 or 3 seconds, you should use probably a progress bar with some percentage, with some estimated time, and so on. Okay? I don't have any bad examples here, but a violation of this heuristic is typically when the design is not providing a feedback. Heuristic number 2, match between system and the real world. The system should speak the user language with words, sentences, concepts familiar to the user rather than system-oriented terms. So you should try to follow word conventions, real world conventions, making information appear in a natural and logical order. So summarizing, use familiar metaphors and language. And here I have some, let's say, possible violations of this heuristic. If I don't know if you recognize this application. It's probably the numbers app on an iPhone, so something like Excel for iPhones. So if I click on the paintbrush here, this icon here, what should happen next? What should happen next? What is, in your opinion, the purpose of this icon? Color the cell, yeah. Something related to colors, right? Instead, so this is the impression that this label also gives to me. But instead, if you click on this icon, you open a very messy formatting menu in which you have to insert typing something. I don't remember exactly related to what, but it's still a formatting menu with text boxes and so on. So as you can see, the icon is not reflecting my mental model of the system and of this specific icon, right? So it's probably an example of a violation because we are not using the convention of the user, a real-world convention in which a paintbrush is typically used to color something. These instead are good examples. Again, here is from iOS probably. In this case, the icon exactly reflects the purpose of the action. So for music, we have a note and so on. And also the trash icon on Mac computers is exactly as the trash in this room probably. And even the interaction with this trash, dragging and dropping something into the trash, resemble what I can do with a trash in the real world. So it's a good example. And here we also have the preview. We can see how the text will be printed on a real world sheet of paper. So this is another good example of matching between system and the real world. So these are some suggestions. You should exploit familiar metaphors, familiar language, so avoid acronyms, familiar categories. And of course, this language will also depend on the target population. If we are developing something for the medical domain, of course, it's normal to use some terms that are well known to doctors and not other kind of users. So it depends also on the target population. Okay? Heuristic number 3, user control and freedom. Users often choose system functions by mistake, that's for sure. So we need to provide users with an emergency exit in case of errors to leave this unwanted state without having to go through an extended dialogue. Support, undo, and redo. So if I'm filling out a form and I insert some wrong field in the form, I should highlight the specific fields that are wrong and not ask the user to recomplete the form from scratch, for sure. And this is, for example, a possible violation of this heuristic. Now I think you can edit messages on WhatsApp. This screenshot was taken last year, but until last year, you didn't have any possibility to edit a message on WhatsApp, okay? So the only way was to use this convention of using the asterisk to fix a possible typo. And this is probably an example of a violation. We are not giving user control and freedom for recovering easily from errors. Can you provide me another example of a violation of this heuristic? Yes? Another kind of application service that works in a way.
Maybe the mail.
Yeah, the mail. If you send an email with some wrong text or a wrong attachment, you cannot modify it. And so this is another example of probably a violation of this kind of heuristic. And these instead are some good examples of providing users control and freedom. Here, for example, you have this menu here on top of this screenshot that is called the breadcrumb menu. It is a design pattern that we will see in a following lecture. But basically, this menu shows your interaction with the website, and you can easily go back to a previous page that you have already seen in your interaction, clicking here directly, for example, on gallery here. Okay, so it's a menu that at the same time shows you the history of your interaction, and you can easily go back in your history. Some suggestions: always provide a back or equivalent button, and in general allow users to explore different alternative paths in your design. Consistency standards. Users should not have to wonder whether different words, situations, or actions mean the same thing. Follow platform conventions. So this is strictly related to the consistency principle that you have already seen before. Again, there is this example of using searching one page and find in another page. It's not consistent. You should use the same label if the functionality of the button is the same. And also you should try to follow the conventions that already exist on a given platform. So for example, the example of the navigation bar on a website, or for example on iPhones, for instance, you have a different way of going back with respect to Android, for example. So you should try to also adapt to the device in which you are developing something. And this is probably an example of a violation of this heuristic. We all know probably the Facebook like. Do you know what is this +1? No. It was used by Google+. I don't know if it's already alive, this social media. It was a social media by Google. And Google used this +1 to counter the Facebook like, okay? But without much success, because no one in this room have used Google+ before. Because Facebook like already became a sort of standard for social media, okay? Adopted also by other social media. You have the like on LinkedIn, you have the like on other platforms. So they didn't follow platform conventions. They tried to use another kind of like, and they failed probably. Okay. And here instead it's a good example of consistency. Here we have two different applications, probably Word and PowerPoint. It's a little bit old, this screenshot, but anyway. But there is consistency, right? So if you learn how to use Word and how to insert a shape on Word, you are probably able also to insert a shape on PowerPoint because the menus are consistent. And also here you have consistency in the menus of Word, Excel, and PowerPoint on a mobile interface. So it's a consistency across a family of different software. So this consistency can be related to the layout, to the dialogues, to the language, and so on. And also the position of elements is important. So the position of navigation elements should be consistent. If you have your back button always on the left, and then in one page you have the back button on the right, This is for sure a violation of this heuristic because the user already know that the back button is always on the left, so she will try to click on the left, of course, to go back. And you should also try to have a consistent meaning for the questions that you are using in the, for example, pop-up messages that you display to the user. So, for example, let's see this example that is taken again from PowerPoint. In the first dialogue there, the question is always, do you want to run this software? And the options are OK, cancel. Do you naturally answer cancel to this question? Do you want to run this software? Cancel. Probably no, okay? If you answer cancel, there is probably something that is not working with your conventions, probably. This is a yes-no question, right? Do you want to run this software? Yes, no. So it's better to use yes, no. But it's better to be explicit, right? To avoid any kind of confusions, any kind of ambiguous questions, ambiguous answers, just be explicit. So do you want to run this software? Run, don't run. Okay, so each button explains the action that is related to that specific button. Okay, so consistency in the dialogues that you use in your pop-up messages. And again, the suggestion is make it explicit. Number 5, even better than good error messages is a careful design which prevents the error. So we know that it's important to provide users with consistent and understandable error messages, but when we can, it's better to prevent errors, prevent the possibility for users to do errors. So inside a form, for example, if you know that there is a mandatory field, maybe you can disable the submit button until the user has completed the form with all the mandatory fields. If you know that your password cannot contain any special character, just prevent the possibility of inserting these special characters in the text box, and so on. And this is an example of a possible violation. I think that in Gmail you have this functionality that if you write, I'm sending you this attachment, and then you forgot to attach the file, there is a pop-up messages saying, okay, you probably want to attach something, but you forgot to attach it. And Gmail doesn't send the email. So in a way, it's preventing the error. And this functionality is, for example, not available on other mailing systems like Yahoo Mail. Okay, so it's probably a violation here. So we are not preventing this specific error that is forgetting to attach an attachment to an email. Here instead, some good examples. Here there is a mandatory field, and again, as I said before, the button is disabled until I attach a file. Other good examples. Here we have an example from Google Search that is trying to correct my spelling. Okay, so Google Search allows me to see the correct term, and I can click on the correct term to perform a good search on Google Search without errors. Or in any kind of travel applications, you cannot select a return date that is before the departure date. So it's disabled, it's preventing the error. Number 6, recognition rather than recall. Here we focus on user memory load. We should try to minimize this load, making objects, actions, and options visible. So the user should not have to remember too many things in interacting with the system. Two good examples in, I don't know what kind of editor is this, probably, I don't know, code block or, I don't know. But you don't have to exactly remember the name of a function. You can just start typing, and then the editor suggests you some alternatives. So you can just recognize your function in the menu without having to remembering the exact name. And another good example are fonts menus, right? You can visually see the font directly in the menu because each font is written with that specific font. So you don't have to remember how the font looks like. You just have to recognize your font in the menu. And this is instead a good example versus a bad example. The task is always the same. It is probably replacing the word hand with or, but this is performed through Visual Studio Code, and this is performed on the command prompt, probably through a VI-like interface. So here on the right, there is no recognition at all. You have to remember the exact command, the exact syntax to replace something in a file. Or maybe you can use Stack Overflow, but you still use 5 minutes of your day to look in Stack Overflow. Here instead, in Visual Studio Code, you just have to recognize which is the replace all button. And when you recognize this button, that's it. You can use it and without remembering anything else. Suggestions: avoid acronyms, codes, use explicit names, provide preview if you can, code completion, page preview, and so on. Okay, flexibility and efficiency of use, number 7. This heuristics is mainly about accelerators that are unseen by a novice user, but can speed up the interaction for the expert. Can you give me an example of an accelerator in a, yes? Shortcuts is a good example of an accelerator. Shortcuts can be used by expert, but the novice can still use the system without using shortcuts, okay? So shortcuts is the first example here. Another example from the iOS keyboard, but you can also do that on the Android keyboard. So the keyboard in general on a smartphone allows swiping through the letters instead of tapping each character individually. And this is an accelerator. It helps expert users probably to type faster, but it can be used, but novices can still use the keyboard by typing on each character separately. So you should have this kind of adaptability, this kind of flexibility, having a default interaction technique maybe, plus some options for the experts. We should take into account that novices and experts have different needs, so we should support proactivity, personalization, and again, different interaction techniques. You can use also recommendations, and also it's important to provide the relevant information only. Okay, we are at heuristic number 8, aesthetic and minimalist design. Interfaces should not contain information which is irrelevant or rarely needed. Every extra unit of information competes with the relevant units of information and diminishes their relative visibility. So this heuristic is also related to fonts, colors, but it can also be relevant to a paper-based prototype because it also refers to the number of information displayed on a screen. And I think that we probably all agree that this is a terrible example of a website, and this page is violating multiple times this heuristic number 8. There is a lot of text, different fonts, different dimensions of these fonts, it's probably a mess, okay? So this page surely violates heuristic number 8. This is instead, I think, a good example. It's not a violation, it's a good example. It's the Google search interface that is clean, uncluttered. It's simple with a minimalist interface. And specifically, the design focuses on the task, the main task that the user can perform on the platform. Okay, so as long as I see this home page, I instantly know what I can perform on the platform. It is typing and searching. So some suggestions. Your interface should clearly display the key information without mixing them with irrelevant content. And of course, again, this can be related to colors and fonts, and also background colors. So also this can be related to a minimalist design. You should also try to have a minimalistic login experience. So I don't know, we will see an example probably tomorrow. If let's imagine I'm trying to book something on a tomorrow we'll see an example about the Trenitalia website. So I'm trying to book a train ticket. Then I discovered that for purchasing this ticket, I need to log in. I try to log in, and what happens in Trenitalia is that your search is destroyed. You are redirected to another page. Okay, it's not a minimalistic user experience, because I would expect that, I do the login, but I stay here in my page and I can continue my procedure from the point that from which I started the login experience. Okay, so the login experience should not interfere with the interaction of the user with your system. Okay. Number 9, help user recognize, diagnose, and recover from errors. So we can have error messages, and these error messages should be understandable by the user, and they in particular should indicate the problem, but also suggest a possible solution. And this is the classic violation of this heuristic, the 404 error page. It doesn't tell the user anything about what went wrong or how they can fix it. So this can easily confuse users. And here instead are good examples. For example, this is the same error of before. It's again a 404 error, but you have an explanation of the error. You also have some alternatives to report the error to the maintainers of the website. So you can also have some information on how to recover from such error. And here instead, it's a good example of error messages in a form. Each error is clearly linked to a specific input field. It's probably a real-time feedback, so it's probably well designed. So errors should be easy to identify. Also with respect to colors and fonts, here we instantly know that there is something wrong in our form. We should highlight the cause of the problem and also the location, and provide also possibly a suggestion to recover from the error. And finally, there is help and documentation. Okay, in theory, our system should be used without the need of any documentation, any tutorial, but there are circumstances, maybe for complex software, in which this kind of tutorials and documentation is important. So it's also better to have this kind of help and documentation. And of course, this kind of information should be easy to search and find in your interface. And here, for example, are some screenshots of I don't know what is this software, but there is this help menu with some images, some tutorials that can be navigated to understand how the system works. This is a screenshot from Slack. I don't know if you have used it before, but there is a bot, a conversational assistant within the platform that is dedicated to this kind of helping procedure. I can ask for help to this bot, and this bot can tell me how to use the platform or how to recover from a given error, for example. And it's quite accessible because I can use it as the other functional, as typing to a friend or a colleague, so it's easy to use. So some suggestions, provide examples, especially in the documentation. Try to use images, tutorials, videos instead of long text, of course. Help the user understanding the gravity of the error, and also provide tips for exploring functionality over in a system. Okay? Any questions? So it was probably a really long introduction to the heuristic evaluation with, I would say, a boring introduction to all the heuristics with a lot of overlap with some principles, but we will use them in some examples and exercises tomorrow. Tomorrow, I think we will have fun in exploring this website of Trenitalia, which is actually, I would say, terrible. Also with respect to the Politecnico website, so it's really, really terrible. And we will find a lot of violations here. So we will perform this example on a real website, and then we will do an exercise on a low fidelity prototype, so to show you something similar to the assignment 3. Okay? If you don't have any questions, I think we can stop here, and thank you for your attention, and see you tomorrow.